This is a video for a generalized framework to display visualizations in CCS. We'll go ahead and start out with project structure, talk about frameworks, analytics, source control and collaboration, go through testing, and finally end up with hosting and performance. So when it comes to the project structure, what I'm referring to here quite simply is what shape or what organization do we need to have within the project. Now the standard convention is what you see here. There is a CSS folder followed by fonts, icons, and images, and then an additional one that holds JavaScript files. Now there is a file that is pointing to these resources. Now there will be some general page, landing page, that guides users to the different types of visualizations that we will have. And what you can see on that same folder as well is the projects that will be these specific visualizations. Now the goal here is to have at the root everything that will be reused, because you don't want users to be loading especially large JavaScript libraries over and over again. If you have a common set of resources at the root that all of the files share, this is by far the most efficient way of organizing it, and that also allows you within the folder, let's say in project 01, to have another organization where you support simply the needs of this specific project. So there we get the best of both worlds. So let's go ahead and go back to our agenda here. The next thing to mention is that for generalized pages, that means pages that do not need specific requirements, or where in addition to the specific requirements you can have some generalized styles. Bootstrap 4 is by far the most widely used, meaning more stable and richest, best supported project. Version 4 is out. It's already in Alpha 6, so that means it is stable enough to start to use, and it has a lot of advantages that are missing from earlier versions. The other thing that we want to have as well, moving on to the next section, is that of analytics. Analytics will let us understand how the site is being used. It will also let us note what is being used the most, which parts have issues, and so on. And so there's a couple of projects. The first one is Heap Analytics. This one is a catch-all type of analytics. It allows one to do pretty rich type of analysis on the data. The other one is more packaged, and it gives you a set of features out of the box, and that's just simply Google Analytics. Both of them are a matter of including a JavaScript block, and within that you can capture data automatically. So it's pretty easy to use. Now the next thing that we should have as well is that of source control and collaboration, and that of course the standard is GitHub. The usual cycle we want to get involved in is one where one person controls the root, and I've created a folder here as a sample. Let me go ahead and show you that. In the name of the project is Ocular, simply as a placeholder and a play on visual. And as you can see, it's empty at the moment. But what we would want to do is we would want every single member that is writing a visualization project to fork this repository, clone it, add, make local additions, and then make a pull request. The person, and it should be one, that is coordinating all of the additions can then control and make sure that there are no conflicts in between projects, and can also run a test against this code before adding it to the root directory. We could also use that root directory or root project to then check out that code and upload it to a hosting environment. And so the address for that is heaps.ocular, as you can see there. Now when it comes to testing, this is something that we want to run, and we want to run with each new upload. It's something that we want to run periodically. And there's three tools really that are the standard when it comes to HTML and JavaScript content. The first one is Phantom.js, and this is headless testing, so that means you do not need an actual user running code or running the test or executing the functions through the browser. You can do that all automatically, and you get the exact same type of data, so you can spot errors, in other words. Mocha and Chai are test runners and test assertions in order to control that workflow. Now, when it comes to machines, DigitalOcean is the least amount of friction when it comes to getting a machine up and running, as I will show here. It has pretty affordable machines. They also provide a set of pre-built machines. That means that when you create a new instance of a machine, you can choose from a number of them. And as you can see, most of the frameworks are supported out of the box. You can see here that Node.js is as well. The other thing as well is that we should run at least 3 machines. That will give us good redundancy, and we should run a load balancer. The load balancer is another feature that is provided by DigitalOcean. It's simply a matter of pointing to the 3 IPs that we already have under the droplets, and that would give us redundancy, and it would also give us speed in case one of those machines was running slow. There's also something to be said when it comes to optimization and performance. For a visual environment, for delivering visualizations to users, you want to make it the fastest you can. And so there's a number of tools and resources that are standard that you can use to improve the compression on images and to make images as small as possible so that they can traverse the web at higher speeds. You can do the exact same thing with HTML, and you can see there the resources that I've listed, as well as JavaScript. So just to give you an example here of something, it is called Uglify because once you run the code through it, it becomes pretty ugly. And you can see here the open source project is just a matter of running that against the code that you have. And I believe this should also be an npm.js project. Let me go ahead and check. And I think it's without the 2. It turns out it needed to be with a -js, as you can see there. And if you take a look at the downloads, you can see there that it's been downloaded 16 million times in the last month. So it's by far the most widely used compression tool for JavaScript. And so certainly, again, as I mentioned at the beginning, you want to make this as fast as possible, and this allows you to compress JavaScript files in a very efficient manner. There's also a couple of tools that allow you to test page performance. PageSpeed is from Google. It is widely used. I'll go ahead and show you here how that works. You simply enter the address, and then you enter the web page. In this case, I'm going to do mit.edu, and you can see there that it's analyzing it, and it's actually giving it a pretty poor score, 49%. It's the score it gives it, and you can see there the should fixes: optimize images, eliminate render blocking, leverage browser caching. If you look at the desktop, I suspect is the same. Yes, it's probably because they have a giant image for the page, and that's probably what it's complaining about. So that's a general overview of some of the best practices, some of the best tools, the resources that you need, testing, and so on for a project to be delivered over HTML using a hosting service. So with that, I'll wrap it up and I'll say goodbye.